Hi folks, I'm welcome you back to Global Education Zone, and this episode I'm going to be teaching you guys how to turn a solid and inclined at 60 degree and also draw the views. So in this case we have this solid. This is the views of the solid, this is the plan, this is the front elevation, and this is side or end elevation of this solid. And in this case we are going to be turning this solid so that the side AB is inclined at 60 degrees to the horizontal plane. So now this is AB here, right here, this side AB. So we'll turn this solid so that the side AB is inclined at an angle of 60 degrees to the horizontal plane, and then I'll draw the key view, which is the front elevation first. Now let's draw it on the right side. So I've already extended the parallel lines, so we just need to locate the points. So you can see this faint line, these are construction lines, these construction lines, and also this one I've also extended this one. I wonder if you can see it, so hopefully you can. Now basically the next thing I need to do now is basically I'll take a starting point. So let me start from here. So now I want to draw the new the key view, which is the front elevation. So this is the point from which my turning takes place. So in this case I'm asked to turn it to be inclined at 60 degrees to the horizontal plane. So in this case I can decide to turn it from here. I can decide to turn it 60 degrees to the right. So if I that's basically what I'm going to do. I'll turn, because now it is inclined at 90 degrees to the horizontal plane. So I will just decrease this angle. That will make it 60 degrees. So when I turn this to the right, I'll just imagine turning it like this. So as if I'm turning the paper. Look at, so it looks as if I'm turning the paper, right? So if I turn it this shape, I would achieve that 60 degrees. So first thing for me to do is the length of this line is 2 centimeters. This is 2 centimeters. So I need to leave 2 centimeter space, and I want to note my point. So this is the point of the so this is the point of A. So I'll draw a line of 60 degrees right here now. So after I've done it, so I'll at the end of the day we'll have the angle of, instead of 90 degrees, we now have 60 degrees. So basically I'll be drawing the former shape inclined at 60 degrees. So I'll need 60 degrees. This is 60 degrees right here. So I'll join that point to A. That would be the new. So the construction line. This is the part that we followed. So the next step is to construct the same shape. So you know that the sides of a rectangle are 90 degrees to each other. So what you need to do is you just draw 90 degree lines at A, so that our next edge will be located in this 90 degree line. Then on the other side we have the height is given as, no, this you are not to change any dimension of the shape, so you are still going to use the same dimension of this figure, but in this case you are just rotating it. So this is the height of this dimension. So I'll also draw the perpendicular to that side, because all the sides of the rectangle are 90 degrees to each other, and this is a rectangle. So then the next step, we need to copy the base, which is 2 centimeters. Just copy the length. So then I will now join a perpendicular to that point for the same reason. So this is the key view. I've drawn the key view. This is the key view, which is the front elevation. So you can see the procedure. This is the procedure of drawing something like this. So now I've drawn the key view. The next thing to do is to get the plan. So I'll just draw verticals from each point. So I need a first vertical line anyway. So let me draw a vertical line at this point. So this is my first vertical line. So I will draw lines parallel to this one for the remaining vertical point distances. This is my key, this is my front elevation. Then I will draw vertical lines for the remaining views. So we have this is for the first edge, you can see. Then for the next edge, this is the edge A. So we can see it when we're looking. No, actually we won't be able to see it. I will use hidden view lines to show that when I stick in my drawing. Then we also have this top one. So I guess I'll need to shift this thing up. So upward, here we go. So this is the top line from the very edge. So we can use this to get the plan. You can see this is where they intersect the line. So I will just need to thicken them. So this is the whole outline of the plan. Yes. So this is how it looks. So I will need to draw the outer edges first. So to get the outline of the plan. So then at the middle we have this edge. So we are going to draw the edge as seen from above. Then also we have a hidden edge below. So we are going to make use of hidden details line. So we are going to make use of 10 short dashes. These are for the hidden details. So this shows that there's. So I'll take in the front elevation now. So which is the key view, because that is the first. That is where the rotation is taking place in the front elevation. So that's why it's called the key view of inclined solids. Now, I haven't done that. This is the plan of this front elevation. So the next step is to draw the end elevation. So I don't know if it's possible for you guys to try that yourself. So I'll also show you. It's possible for you to try that yourself though. It's actually very simple. Just measure the side. Now I will note that this front elevation is along this side, so the end elevation will be along this alternate side. So that's what you should know. So I'll draw verticals from that. Now I won't need to draw any project any lines from the plan, because you can see that all these lines are vertical. So the only lines I would have been able to project are the horizontal lines from the plan. So since they are all vertical, the only place I'm projecting from is the front elevation. So I'll just project the end of the end elevation right here. This is the end elevation. Then the next thing is the end elevation will also have the height of the front elevation. So basically in this case, the height will be adjusted here. We'll have a bigger height. So I will then I begin transferring the horizontal distance from the front elevation. So I have this horizontal distance. This is actually hidden. So but this is visible. Okay, actually it is in this end elevation here, because of we are in first angle projection, right? So that means the end elevation of the right is actually the left. So that means this is the one hidden. So this is what we use dotted line. So I will now take in the outline of the end elevation of the end elevation. Yes, this is the outline of the end elevation. Outline of the end elevation that we have this one. So then we have this one. So also this is hidden from the left side. So I'll use hidden short dashes. But this is visible from that side. So I'll use a thick outline. So and finally that is the end elevation. This is the front elevation. This is the plan. This is the end elevation. So you can see that when we rotate this shape, when we rotate this shape, this is what we get when we finish the rotation. Thanks for watching.